This video is on special right triangles. Recall from geometry that there are two special right triangles, a 45-45-90 right triangle and a 30-60-90 right triangle. In a 45-45-90, the two legs are congruent because the two angles are congruent, and the hypotenuse is equal to the length of the leg times the square root of 2. Here's a little formula I've come up with. Hypotenuse equals leg times the square root of 2. Let's take a look at a couple examples here. So for the first one here, we have that the length of a leg is 6, and I don't know what the hypotenuse is. So using my formula, hypotenuse equals leg times the square root of 2. I substitute in x for the hypotenuse, 6 for the leg, times the square root of 2. So the length of each leg is 6 square root of 2. Let's switch those values now, and now I know that the hypotenuse is 8, but I don't know the length of a leg. So I can use hypotenuse equals leg times the square root of 2. My hypotenuse is 8. My leg is x times the square root of 2. Dividing both sides by the square root of 2. Those will cancel out, and I have that x equals 8 over the square root of 2, but I need to rationalize my denominator by multiplying by square root of 2 over square root of 2. So that gives me that x is equal to 8 square root of 2 over 2, and I can actually cancel the 8 and the 2, which leaves me 4 square root of 2. So each leg is 4 square root of 2 units long. In a 30-60-90 right triangle, the relationship between the sides is as follows. The short leg is opposite the 30-degree angle, the longer leg is opposite the 60-degree angle, and is equal to the short leg times the square root of 3. The hypotenuse is equal to 2 times the short leg. And here's two little formulas I've come up with. Long leg equals short leg times the square root of 3, and hypotenuse equals 2 times the short leg. Knowing that, let's take a look at, we actually have 3 examples here. So in the first one, I have that my short leg is 3, my long leg is x, and that short leg is 3 because that's the side that's opposite the 30, the long leg is opposite the 60, and y is my hypotenuse. Since I know the short leg, I'm going to start with that. So I know that the hypotenuse is equal to 2 times the short leg. My hypotenuse is y. My short leg is 3. So my hypotenuse is equal to 6. Now I can use that long leg is equal to the short leg times the square root of 3. My long leg is x. My short leg is 3, square root of 3. So in this right triangle, when my short leg is 3, my long leg is 3 square root of 3, and my hypotenuse is 6. Over here, I have that my short leg is x, my long leg is y, and my hypotenuse is 8. So since I know the hypotenuse, let's start with that. So hypotenuse is equal to 2 times the short leg. 8 equals 2 times x, or x is equal to 4. So my short leg is 4. Now I use my other formula. Long leg equals short leg times the square root of 3. My long leg is y. I just found that my short leg was 4, square root of 3. So in this triangle, my short leg is 4, my hypotenuse is 8, and my long leg is 4 square root of 3. Those are two examples that are pretty straightforward. The hardest example is this one here, where you are given the long leg and you have to find the short leg and the hypotenuse. So x is my short leg, y is my hypotenuse, and 6 is my long leg. Now, both of the formulas that we have actually use the short leg, but I don't know the short leg, so I can't use hypotenuse equals 2 times the short leg. So I'm going to have, the only thing I know is the long leg, so I'm going to have to start with that one. So long leg equals short leg times the square root of 3. 6 equals x square root of 3. Solving for x, we divide both sides by the square root of 3. And so I have that x equals 6 over the square root of 3. Have to rationalize my denominator. So x is equal to 6 square root of 3 over 3. And I can cancel. And x is equal to 2 square root of 3. So x was my short leg. That's 2 square root of 3. Now I can do hypotenuse equals 2 times the short leg. or y is equal to 2 times 2 square root of 3, and I can just multiply the numbers out front, 4 square root of 3. So in this 30, 60, 90 right triangle, my short leg was 2 square root of 3, my long leg was 6, and my hypotenuse is 4 square root of 3. Now what I'd like you to do is to try to do these problems on your own. So here we have 45, 45, 90 right triangle and two 30, 60, 90 right triangles. And in each case, the hypotenuse is 1 unit long. And I'd like you to try to find the lengths of the legs of these. This is really going to help us when we get into the unit circle and start doing some trigonometry. So I'm going to pause. I'd like you to pause the video and give these a try. Okay, let's take a look at what we have here. So in the first one here, I have a 45, 45, 90. So I'm going to just leave it as leg. So hypotenuse is equal to leg times the square root of 2. My hypotenuse is 1. I'm going to leave the word leg. Square root of 2. Dividing both sides by square root of 2. And then rationalizing my denominator, I get that the length of each leg is equal to square root of 2 over 2. Let's take a look at the 30, 60, 90. Here I have a short leg, here I have a long leg, and actually it's going to be the same for both of them. So I know my hypotenuse is equal to 2 times the short leg, or 1 is equal to 2 times the short leg. Dividing both sides by 2, my short leg is equal to 1/2. And then I know that my long leg is equal to the short leg times the square root of 3. So my long leg is 1/2 times the square root of 3, or the way that we write that is long leg equals square root of 3 over 2. So my short leg is going to be 1/2. My long leg is going to be square root of 3 over 2. And I'll go ahead and put those in over here. This is 1/2, and this is square root of 3 over 2. So in this video, we did a short little review of the special right triangles of 45, 45, 90 and a 30, 60, 90, and the formulas that are really helpful if you have those memorized for figuring out what you need to know.